Today we are going to discuss direct variation. In the Big Ideas book, this is section 5-6. These are the notes that I'm going to be using to talk about direct variation. When you do direct variation, the key is, and I'm actually going to come down here first, that it passes through the origin. So we're going to say direct variation where k is a number. So two quantities, x and y, show direct variation when y equals k times x. This is where k is a number. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, half, whatever. But k does not equal 0. Now another piece of direct variation is, if it is in direct variation, then it will pass through the origin. And you should remember that the origin is 0, 0. Okay. When it does this, when it passes through the origin or has an equation that looks like this, the k is called your constant of proportionality, and you'll be asked to find that k. All right, so what does this mean? How do we do this? All right, you can kind of see my graph here. Hopefully yours showed up a little bit better. I am going to go ahead and graph these points. Okay, so I'm going to go ahead and just sketch out my axes. I don't have any negatives on this, so I'm just going to give myself the quadrant 1, or positive side. Now, when x is 1, y is 3. So I'm going to count up 1, 2, and 3. So this is when x is 1 that I get 3. When x is 2, I get 6. So there's 3, 4, 5, and 6. So this is when x is 2. I get y is 6. When x is 3, I get y is 9. So there's 6, 7, 8, and 9. And then when x is 4, I get 12. So 9, 10, 11, and 12 is right there. Now what we need to do is you need to find a straight edge, and you need to connect these points. Don't just try to eye them up. Get something, piece of paper, something, and sketch. When we do that, you can see that I go through this 0, 0 point. Because I go through the 0, 0 point, this is proportional. This is direct variation. So this, yes, because my line goes through the origin. So x and y are in direct variation because they go through the 0, 0 point. Now, you don't always have to graph it, which is really good. So for instance, if you're giving an equation, what we could do is we could solve for y. So when I solve for y, I need to get y alone, so I'm going to move the 2 to the other side, and I'm going to do the opposite of a plus 2, which means I'm going to subtract 2 from both sides. I get that 0 pair, they go away. I'm left with y equals. Now, these are not like terms, so we're going to keep them separate. We're going to put x minus 2. Now, if we look back down to where we wrote what direct variation was, it has to have the equation y equals kx. But when I look up here, I have y equals, we could say k is 1, right? We could say that. So kx, but this has this minus 2. With that minus 2, it is not proportional because it does not fill fit this equation y equals kx. So, no, this is not a direct variation. Because y does not equal kx. All right. Now, sometimes you're told the variables x and y vary directly, so it is a direct variation. What we're going to do is we're going to use the values that are given to find the constant of proportionality, which we know is our k, and we're going to write an equation that relates x and y. So we are going to write the equation of y equals kx. All right, so to do that, we're going to start with y equals kx. We're going to plug this y in. So we have y is 8. We're going to plug it in for the y. We don't know our k value. And we're going to plug in our x is 2. So our x value, let me use a different color, is going to be 2, and we're going to plug that in for x, where we plugged in y equals 8 for the other one. Okay, now k times 2 or 2k, right? You can rewrite it if you need to. But I want to solve for my k, so what I need to do is I need to divide both sides by that 2, and we're able to solve for k, and k equals 4. Now, you need to finish this and actually write the equation. So we're going to write y equals k, but we now know our k value, it's 4, times our x, or just y equals 4x. So this is the equation for these points that are vary directly. We also found our constant of proportionality, which is k equals 4. Alrighty, and on the next one, let's try this one. We're going to start with y equals kx. We're going to plug in our y value of 14. So I'm going to put that in for my y. And that's going to equal k. And then I'm going to put in my x value of 16. Now to solve this, I need to divide both sides by that 16. Those 16s go away. That's our identity. We're left with k equals 14 over 16, but we know we have to reduce. And these are both even, so I can divide both of these by 2. 14 divided by 2 is 7, and 16 divided by 2 is 8. We're going to leave this in fractional form. If you think back to our slope, we're going to leave it there. So y equals our new k value, which we found to be 7/8 x. And this is the equation for these points that vary directly. So this is direct variation with our constant of proportionality, k.